So, Synopsys solutions for RISC-V. We've actually got four large categories of solutions. The first one is processor verification. So we've got both formal tools and dynamic verification tools for people that are building their own processors, for people that are taking an open source core, or for people that are even taking a licensed core and adding custom instructions to it. A second major category in the design flow is early architecture exploration and software development. And here we have a couple of tools. One, the ASIP Designer tool that helps to build accelerators, and then also Platform Architect for SoC performance analysis. Also here in this category, we have virtual prototyping for early software development. Third category is accelerating software development with hardware. These are the hardware accelerated verification tools, HAPS and ZeBu. They enable people to start software development months before the hardware is available. And these actually, while I've on the slide mentioned software development, these also get used in hardware software co-verification flows. And then the fourth category in this broad spectrum of RISC-V solutions from Synopsys is IP. And specifically here, we're talking about the ARC-V IP. ARC has been building processor IP, more importantly, delivering processor IP for more than 25 years. This is not a new startup doing RISC-V. This is an established processor IP vendor that is using the RISC-V instruction set architecture. So that's the range of solutions. Let's go into a bit more detail on this, starting with processor verification solutions. And here we see that we've got the formal and dynamic verification. On the formal side, this is both the conventional property checking solutions as well as equivalence checking. Equivalence checking here being used for data path verification, and also the sequential equivalence checking. And this is actually a really nice technique for ensuring that your custom instructions are not breaking the base RISC-V core that you're adding to. On the dynamic verification side, we have test generation solutions, Sting, and also Empirus TS test suites. Empirus DV is a co-simulation and checking processor verification environment. Key components of this are the Empirus FPM fast processor model that supports the full RISC-V specification, also supports custom instructions, and then also Empirus FC, the functional coverage. And as we know, functional coverage is the key metric for processor verification. And these tools all work with the conventional simulation, VCS and Verdi, and also with hardware-assisted verification, ZeBu and HAPS. And then there's the ability to have functional coverage and verification planning combined between the formal and the dynamic verification tools. So that's on the verification side. This is a little bit more detail on formal verification. Here we see the formal property verification, the model checking, and we see that this is supporting the full instruction set architecture for RISC-V. And then going down with the DPV equivalence checking, the data path verification, the sequential equivalence checking, formal register verification, and even security verification. And with RISC-V as a primary choice for security processors in SoCs, this formal security verification is actually a really nice tool to have. A key piece in the dynamic verification environment are the fast processor models, the Empirus FPMs. We can see the architecture here, that there's a base model, the ability to configure that within the spec, and the ability to add custom instructions. This model then can be used with virtual prototypes, the virtualizer tool from Synopsys, and also gets used as the reference model in verification. And the nice thing here on the verification side is that we've been doing this for a while. This Empirus FPM processor model has been used in verification of processors for more than I think it's, more than 50 SOCs. So there's a significant, actually, proof case here. Also, using the same model for both hardware and software verification enables significant reduction in SOC bring up time. This is a bit more detail on the processor verification solution, showing that co-simulation environment within Synopsys VCS, Verde reporting the functional coverage results, and then Sting, Empirus, TS, and the RISC-V ISA test, compliance tests that are sitting there and driving the environment. This enables you to have the configurable, extendable RISC-V reference model, do the simulation in VCS, have the scoreboarding and checking already built in, and then report the functional coverage out to Verde. Sting is one of the key pieces of that verification environment. Sting is the leading test generation tool in the RISC-V community. What Sting does, it has a few modes of operation, can generate constrained random, directed, and graph-based tests. These are used in the verification of the RISC-V processor. And Sting also works on multiple platforms. It works on the basic RTL simulator, but it also works on hardware emulation, on FPGA prototyping platforms, and also on the real silicon. I mentioned before that we have two tools for architecture exploration. One is the ASIP Designer tool, the other is Platform Architect. ASIP Designer provides a methodology for inputting the details of your RISC-V processor, the coprocessor, the accelerator that you're going to be building. And from that description of the processor, it outputs the RTL. It also outputs the software development kit. The software development kit, including things like the compiler and the rest of the tool chain. And then Platform Architect is the industry leading tool for SOC performance analysis. What we've done with Platform Architect is to add the capability there to have a RISC-V processor that is driving the SOC and have RISC-V workloads inside of Platform Architect. Virtual prototyping is a mainstream tool now for early software development. This is enabled in the RISC-V community by the Empirus FPM RISC-V model. And actually last week, Infineon announced the availability of a virtualizer VDK, a virtual prototyping platform with the virtualizer tools, and actually includes models from Synopsys. So the idea with virtual prototypes is to shift left software development. There's no RTL needed. You can be a lot earlier in your design flow to get the software development going. And here it also provides a comprehensive software development environment for AI and automotive and other industries, but especially if we think about AI and optimizing the AI algorithms for the distributed architecture that is usually implemented for AI. Virtual prototyping is a great tool for doing that. We have support for all the major RISC-V processor IP vendors and also for customers that are building their own RISC-V processor. This technology is also great for customers that are using continuous integration, continuous deployment methodology for their software development. The nice thing about virtual prototypes here is that they're quite fast. Here we're talking about running at hundreds of millions of instructions per second, or booting Linux in approximately 6 seconds on a normal PC. Hardware-assisted verification on FPGA prototypes with the HAPS prototyping solution and on the ZeBu hardware emulator are also two great tools to be using with RISC-V. FPGA prototyping on HAPS, again, industry standard methodology, and we've supported RISC-V on this. Actually, at shows last year, we were collaborating with Andes and showing an AI accelerator built with Andes RISC-V technology running on HAPS. ZeBu emulation is the other tool, the emulator tool, and We show here that it works with real RTL for the processor model, but it can also work with a virtualized model so that you can very quickly boot to Linux and then transition from the virtual prototype into the emulator so that you don't have to run at the slower emulation speed for Linux boot software stack testing. Last but certainly not least is the ARC-V processor IP. Again, this is the ARC team that has been building processor IP for decades. We have three families of IP, the RMX, RHX, and RPX series. So these are microcontroller, real-time, and higher performance processors, building on more than 25 years of customer success and leading PPA efficiency. There's also all the tool chain, all the other tools that you're going to need here, and the full ecosystem of software tools that you want for your SoC development. The ARC-V IP is ISO 26262 safety certified, and also the ISO and SAE cybersecurity compliant. Because this is all within Synopsys, the ARC-V Synopsys solutions work with the Synopsys tools to accelerate SoC development. So just summing up here on the RISC-V solutions, Synopsys is uniquely positioned to support the expanding RISC-V processor ecosystem. The ARC-V processor IP is based on more than 25 years of customer success. We have a comprehensive suite of EDA tools and reference methodologies for successful implementations of RISC-V processors and SoCs. We also have expert design services to accelerate customer enablement. And these solutions, both the IP and the tools and the models, are silicon proven with success with leading companies across a range of applications, including hyperscalers, AI, memory, storage, IoT, automotive, across the board. We welcome more discussions with you. We welcome collaboration with you. More information at synopsys.com/RISC-V. Thank you very much.